3 magnitude 7+ earthquakes, Tonga, Vanuatu, Indonesia, all in the same week. And then a magnitude 6 strikes Australia. Not the edge of Australia, the centre, a place 1,500 kilometres from the nearest plate boundary, on crust that has been geologically quiet for hundreds of millions of years. That sequence is not a coincidence, at least not one anybody can confidently dismiss. At 3:26 in the morning, on April 5th, 2026, people sleeping near Uluru were pulled out of their beds by something they could not immediately explain. Not a sound first, a feeling. The ground under one of the most iconic landscapes on Earth was moving. Light fixtures swung from ceilings. Objects slid off shelves and hit the floor in the dark. Guests at the Sails in the Desert Hotel in Ulara stumbled into corridors half asleep, looking at each other, trying to work out whether they had dreamed it. They had not dreamed it. A magnitude 6.0 earthquake had just struck 10 kilometres beneath the Australian outback, with its epicentre sitting roughly 80 kilometres south of Ulara, a small township that exists almost entirely because of its proximity to Uluru. By early Sunday afternoon, more than 30 reports had been filed with the National Earthquake Alert Centre in Canberra. Beyoncé Matthew, who was on the night shift at the hotel when it hit, said some guests were jolted awake by the rumbling. Geoscience Australia senior seismologist Jonathan Bathgate went on ABC radio and described light to moderate shaking across the region. Things rattling from shelves, light fixtures swinging. A bit of an early morning wake-up for quite a few people. A magnitude 3.4 aftershock followed just after 9 a.m. No injuries, no structural damage anywhere in the region. And in the hours after, when the initial shock wore off and people started asking the obvious question, the scientists monitoring the data were already asking the same one. Not how bad was it, but why did it happen there at all? Most of the world's earthquakes happen in places you would expect them to happen. The Ring of Fire, the Himalayan collision zone, the San Andreas Fault. These are active boundaries where tectonic plates grind against each other daily, and large earthquakes are built into the geology. You grow up near those places, you know the risk, you plan for it. The Australian outback is not one of those places. The epicentre of this earthquake sat approximately 1,500 kilometres from the nearest plate boundary. To put that distance in perspective, it is roughly the same as the distance between London and Moscow. The ground that shook on April 5th is sitting in what geologists classify as a stable continental region. That is the technical term for ancient, cold, undisturbed crust that has not been near an active plate boundary in hundreds of millions of years. It is the geological equivalent of bedrock in every sense of the word. A few magnitude 5 earthquakes occur across Australia in an average year. Smaller tremors get picked up by seismographs regularly, but a magnitude 6 in the deep interior, in the Amadeus Basin region of the Northern Territory, surrounded by red desert in every direction, sits in a different category entirely. The last time the world saw seismic data coming from this part of Australia, it caused scientists to rewrite their understanding of what stable continental crust is actually capable of. And that story starts in 1988. On January 22nd, 1988, the Northern Territory broke open without any warning that the outside world had noticed. Not once, 3 times. 3 separate earthquakes, magnitude 6.3, 6.4, and then 6.7, hit the area near Tennant Creek within a single 12-hour window. The ground tore along 2 fault scarps for a combined length of 32 kilometres. You could see the rupture from the air. The hospital in Tennant Creek was seriously damaged. Underground pipelines were ruptured. In the following year alone, more than 15,000 aftershocks were recorded by the nearby Warramunga seismic array. The shaking from those 3 earthquakes was felt across more than 1/4 of Australia's entire land surface. High-rise buildings in cities up to 2,000 kilometres from the epicentre moved. People in offices in Adelaide and Brisbane felt their floors sway from a sequence of earthquakes happening 1,500 kilometres away in the desert. It remains one of only a handful of intraplate earthquakes in recorded history to have produced documented surface rupture inside a stable continental interior, a category so rare it sits on the same shortlist as the 1811 New Madrid sequence in the American Midwest. The 1988 sequence forced geologists to revise a model they had held for decades. Australia was not aseismic. It was not immune. It was simply sitting on ancient fault systems, structures formed during mountain building events that ended hundreds of millions of years ago, that had been locked under compression for so long that nobody had seen them move in living memory. Locked, not gone. And the April 2026 earthquake near Uluru sits in the same geological neighbourhood as Tennant Creek. The same ancient Precambrian crust, the same buried fault architecture, the same category of event that the world had decided was not supposed to happen there. Until it did. Here is the part that most coverage of this earthquake skipped over entirely. Australia is not sitting still. The continent is moving northward at roughly 5.6 centimetres every year, which makes the Indo-Australian plate one of the fastest moving tectonic plates on Earth. And it is moving that fast because it is being driven by collisions happening simultaneously on multiple sides. To the north, it is pushing into Southeast Asia and the Eurasian plate, the same slow-motion collision responsible for building the Himalayas, still ongoing, still generating pressure. Along its eastern and northeastern edges, it meets the Pacific plate along the Ring of Fire, the boundary that produced the major seismic activity in Tonga, Vanuatu, and Indonesia in the days surrounding this event. The critical thing to understand is that the stress from those boundary collisions does not stay neatly at the edges of the plate. It travels inward, through the entire mass of rock, all the way to the interior, and it accumulates there, in exactly the kind of ancient locked fault systems that sit beneath Central Australia, until something gives. There is a deeper structural shift happening that makes this more significant. The Indo-Australian plate is not moving as a single rigid unit anymore. Satellite data and seismic records show that the Indian portion and the Australian portion are pulling in slightly different directions. Australia is moving faster. India is being slowed by its collision with the Himalayas. The result is internal deformation building up inside the plate itself, compression, differential movement, stress concentrating in the zone between them. Some researchers now believe the plate has already effectively begun separating into distinct subplates, with a diffuse deformation zone running through the middle of the Indian Ocean. What that means practically is this: the interior of Australia is not insulated from what happens at the plate boundaries. Those boundaries are loading the interior from the outside in. Every major subduction earthquake along the Ring of Fire sends seismic waves radiating outward through an already stressed system. Scientists call this dynamic stress triggering, the idea that a fault sitting close to its failure threshold can be nudged across that threshold by the passing energy of a distant large earthquake. It has been documented globally. It is not a theory, and it is one of the most credible explanations for why the ground beneath Uluru moved on the same weekend that the broader Indo-Pacific region was producing some of its most intense seismic activity in years. The tourists who woke up at 3 a.m. had no idea any of that was underneath them. Most people never do until the floor starts moving. There is a phrase that keeps appearing in the official statements about this earthquake: stable continental region. Scientists use it. News reports repeat it. And on the surface, it sounds reassuring, like stable means safe, like the ground there has some kind of geological guarantee attached to it. It does not mean that. Stable continental region is a classification that describes distance from active plate boundaries. It describes the age and rigidity of the crust. What it does not describe is risk. Because here is the thing about stable crust that almost nobody talks about outside of academic geology. When it does break, the shaking travels farther and hits harder than the same magnitude earthquake would anywhere near an active boundary. The rock is older, colder, more rigid. Seismic energy does not get absorbed the way it does in younger, warmer crust near active zones. It propagates. The 1988 Tennant Creek sequence was felt in high-rise buildings 2,000 kilometers away. A comparable earthquake on the San Andreas Fault in California would have been absorbed within a fraction of that distance. So when the official language describes Australia as a stable continental region and then notes a magnitude 6 earthquake in its interior, those two things are not cancelling each other out. They are sitting side by side. And the second one is more surprising precisely because of the first. The stability is exactly what makes an earthquake there so significant. A magnitude 6 in a place built to handle magnitude 6 events regularly is routine. A magnitude 6 in crust that has been locked and compressed for hundreds of millions of years, sitting 1,500 kilometers from the nearest plate boundary, with seismic waves that will travel across a quarter of a continent before losing meaningful energy, that is a different conversation entirely. In the days surrounding the April 5th earthquake near Uluru, the Indo-Pacific region was not quiet. It was running some of the most intense seismic activity seen in that part of the world in years. Major earthquakes had struck Tonga, Vanuatu, and Indonesia in close succession, all of them magnitude 7 or above, all of them along the Ring of Fire, all of them on the same broader tectonic system that the Australian plate sits against. Now, the important thing to say here is what scientists are actually careful to say. Those earthquakes did not directly cause the Australian event. Subduction zone earthquakes and intraplate ruptures are completely different mechanisms. One happens where plates are diving beneath each other. The other happens inside the plate itself, along buried ancient faults. There is no straight line of causation from Tonga to Uluru, but there is a connection, and it runs through the physics of how seismic waves move through rock. When a magnitude 7 or larger earthquake ruptures, it does not just shake the ground near the epicenter. It sends energy radiating outward through the earth in every direction. Waves that travel thousands of kilometers, gradually losing strength, but never fully disappearing until they have circled the planet multiple times. When those waves pass through a region where a fault is already sitting close to its failure point, already loaded with stress, already compressed, already on the edge, they can be enough. Not enough to cause the earthquake on their own, but enough to be the final increment of pressure that crosses the threshold. Scientists have documented this effect at volcanoes, at geothermal fields, at fault systems on multiple continents. The mechanism is real. It is called dynamic stress triggering. And the timing of what happened in Central Australia on April 5th, sitting inside a window of unusual regional seismic activity, makes it impossible to dismiss. Australia does not have a seismic risk conversation the way Japan does, or California does, or Turkey does. It does not need to most of the time. But there is a version of that conversation that has been slowly building in the scientific literature for years, and events like April 5th bring it back to the surface. Geoscience Australia has been clear for some time that the country's seismic hazard is real and unevenly understood by the public. The populated southeast of the country, Melbourne, Adelaide, Canberra, sits on crust that has produced damaging earthquakes before. The 1989 Newcastle earthquake killed 13 people, injured more than 160, and caused over $4 billion in damage. It struck a city that had essentially no seismic preparedness, no building codes designed for earthquake resistance, and a population that had no cultural memory of the ground moving beneath them. Newcastle was not near a plate boundary either. It was an intraplate event, and it remains the most economically damaging natural disaster in Australian history. The April 2026 earthquake caused no damage. The location was remote enough that even a larger event in the same spot would likely cause no casualties. But the location is not the point. The point is what it reflects about the stress state of the plate underneath the continent right now. Stress does not choose convenient locations. It releases where the weakest point is at the moment the threshold is crossed. The outback near Uluru was that point on April 5th. The next point could be anywhere the same ancient fault architecture runs, and those structures extend across large portions of the Australian interior, some of them running in the direction of areas that are considerably less empty than the Amadeus Basin. Australia is moving north at 5.6 centimetres per year. That number sounds small. Over a human lifetime, it adds up to less than 5 metres. But plate tectonics does not work on human timescales, and the forces building up in the Indo-Australian system are not small. The collision happening to the north, the same slow grind that built the Himalayas over 50 million years, is still ongoing. The differential movement between the Indian and Australian portions of the plate is still widening. The stress is still accumulating in the interior. None of those processes have a pause button. The tourists who filed reports in Canberra on Sunday morning described being jolted awake in the dark, hearing things fall in their rooms, feeling the ground move beneath a place that the entire world thinks of as ancient and permanent and still. Uluru is 600 million years old. The rock that forms it has been sitting in roughly that position since before complex life existed on this planet. And on April 5th, 2026, the ground underneath it moved. That is not a reason to panic. No scientist studying this region is suggesting imminent catastrophe. The monitoring systems are running. The data is being collected, The aftershock sequence is being tracked in real time. What happened near Uluru on April 5th is, in the formal scientific language, consistent with normal intraplate stress release in a known geological setting. But normal and expected are not the same word. Australia has been shaken by events like this before, in 1988, in 1989, in scattered sequences across the interior over decades. Each time, the official response is measured. Each time the public is reassured that it falls within understood parameters, and each time the question that does not fully go away is the same one. Not whether the stable continent can produce earthquakes that shock the world. April 5th already answered that. The question is what it is building toward, and how much pressure is still left to release. The ground near Uluru is quiet again now. The aftershocks have settled. The tourists have gone home. But underneath that red desert, the same ancient faults that moved once are still there. Still locked, still compressed. And the plate they sit on is still moving.